Okay, this is what's my sine cosine lab 2 for pre-calculus, and I'm doing number 7, which talks about the following table shows the average daily maximum temperature in degrees Fahrenheit in Boston each month. It says plot the average daily maximum temperature as a function of the number of months past January. So what they mean by that, and they want us to find a trigonometric function, approximation, because it's not going to be perfect, is when I do this at first, so I don't have a shift, I'm going to call January 0 and then accordingly go through and number the rest of these. The reason why is as you do this and I ask you for answers for certain questions, what'll happen is that you'll pick the wrong month. For example, I think April's the 4th month, but in here, because I don't want to graph with a shift, January 0, so April will be a 3, okay? So then we're going to find a trigonometric function approximation, and then we're going to use the formula to find some information. So the first thing I did was look at the high and the low, because this helps you set up your graph. And I see it goes all the way up to, what's it, 81.8. So I'm going to go up to 90. And the lowest goes down to, let me see now, 36.4. Is there, no, there's a 35 over here. So you can actually go through and graph this pretty much, and you can actually show if you want to a break in the graph, but this one actually works pretty nicely without the break, but just so you know how what your numbers are going to be doing. So the first thing is I set up the temperature, and as you can see, I went from 0 to 90 here for the temperature in degrees Fahrenheit, and January 0, and then here the T is in months, so I'm going to make this look a little nicer. So 11 is December, okay? And I kind of counted every single one as 1, so this will be 10, and this is 12, so 11 is going to be there. And this is T is in months. Okay, so what you do now is we're just going to go ahead and plot all the points. So have your graph ready. I just can't show it all on the screen. So 0 is 36.4. So this is 35. So it's going to be like in there. And 1 for February is 37.7. So that's going to be about almost very close to that. 2 is 45. So that comes about here. So I counted by 5s on the y-axis. And then that's 45. For 3, it's 56.6. For 4, it's 67. For 5, it's 76.6. So you're getting up here. For 6, it's 81.8. For 7, it's 79.8. So you're right here. For 8, it's 72.3. About here. For 9, it's 62.5. So you're about here. 10 is 47.6. And 11 is 35.4. Okay, so let me get rid of these extraneous dots. And then all I did was just swing the best curve I could through the points, and it's not going to be a perfect thing. It's going to be more of an approximation. So there's my curve. By looking at it, it looks like a negative cosine curve, so that's good to know when we do the formula. So let's start here. So I already plotted the average, so B is find the trigonometric approximation. So I'm going to do looks like. Amplitude, frequency, period, midline. And I always start with midline. And so I'm going to take the high which is 81.8. So we're going to be very specific, plus the low, which is 35.4, and I'm going to divide by 2. So I have y equals 58.6. Before I do any more, I'm going to say it looks like negative cosine. I'm actually going to go on and graph 58.6. So 58.6 will look about this way. Let me see if I can find a different color. So 58.6 would be like in here somewhere, which does look like the middle. I always check that. So now I'm going to come up. My amplitude is high minus my midline. Whoops. High minus my midline. So the high is 81.8 minus my midline, which is 58.6. So I get 23.2. My period, even though it's going from 0 to 11, it's still 12 months. I just didn't want to have a shift in there. So it's going to be 12 equals 2 pi over my frequency. Solve for my frequency by cross multiplying. So you get your frequency is pi over 6. So my temperature equation comes out to be this. So I'm going to use a big T for temperature, is going to equal negative 23.2 cosine, because remember it's inverted, okay, pi over 6t plus 58.6. So we found an approximation of this data. It's not perfect, but close enough. Now for the C part, they want us to find for C, use your formula to estimate the daily maximum temperature for October. Now you got to be careful, October is 9. And then you want to see how well it fits the data. So I'm actually going to plug a 9 in the T spot. So I'm going to do the temperature is negative 23.2 cosine pi over 6 times 9 plus 58.6. And make sure, please, that you're in radians. And when I do, I get the temperature to be 58.6 degrees Fahrenheit. So how well does this match our graph? Well, it's versus 62.5. So it's about maybe 4 degrees less than it's supposed to be, but it's not bad for an approximation. So that's how you do this one. And this is the graph that goes with it. So I hope that helped.